Mathematica has some very powerful tools for dealing with lists of elements, and I'm going to very, very briefly show you just a little bit about how lists work. The first thing that I'm going to do is I'm going to clear everything in Mathematica. I'm using this clear command, and in order to clear everything, I put inside the clear command this particularly strange syntax in this form. This is what gives you a really clean slate in Mathematica to start with. And what's in there is a double quote, the word global with a capital G, a backtick, an asterisk, and then a second double quote symbol. And that backtick is the upper left-hand corner key on my keyboard. It's the same one that has the tilde on it. So make sure you get that backtick correct. It's not just an apostrophe. So I'm going to clear everything. I enter commands using Shift-Enter, and I've cleared everything that had been previously set in Mathematica. I'm starting with a completely clean slate. Okay, then, in order to make a list of quantities, I can use the table command. In this particular case, I'm going to make a list of quantities that are pi over n squared, and I'm going to iterate n through a range of values. And so this quantity right here, pi over n squared, that's the quantity that's going to go in the table. And then here in the braces, I'm giving the instructions to Mathematica about what values of n I want it to take. And what this set of instructions tells Mathematica is I want to iterate n, I want it to start with the value of 1, and I want it to end with the value of 3. And since I haven't given it any more information, and these are both integers, it's going to iterate it by 1. So let's go ahead and execute that. And you see it makes that list for me of those three quantities with n is equal to 1, n is equal to 2, and n is equal to 3. Okay, so that's a really simple way to make a list. And I have those three quantities that I wanted to make in the list there. Let's do a couple more things with this. So suppose I didn't want to iterate by 1, 1, 2, 3. Suppose I wanted to iterate by 2, where I go 1, 3, 5, and let's make our list 10 long now. And so now, again, what this is going to do, it's going to iterate the same expression for me to calculate pi over n squared. The value of n is going to range from 1 to 10, but it's going to go by 2, so it'll go 1, 3, 5, 7, 9. We'll go ahead and execute that, Shift-Enter, and you see, in fact, that's made me this list of, this table, this list of that quantity iterated with n is equal to 1, 3, 5, 7, and 9. And so that's, again, another way to iterate with a list. One of the things to note is that pi is an exact numerical value in Mathematica, and one of the nice things about Mathematica is if you give it exact numerical values and integers, it will not evaluate those. It will keep those as those exact numerical values, and that can be useful in terms of exact expressions, using Mathematica to give you exact expressions for quantities as opposed to numerical values. I can always find the numerical values for that expression, for an expression, by using the n command. The n command just tells me to give me the numerical value. So let's go ahead and put an n command around this table, and you will see that in fact what I get is the numerical values evaluated. And so there are the numerical values, but those may not have as much meaning to me if I'm looking for how this particular parameter varies as a function of pi. So again, that is one of the nice aspects of Mathematica. Okay, let's do one thing. Let's make our table 500 elements long. I can make the table as long as I want it. Mathematica is fine with doing that. And this should produce a table of this guy with 500 elements in it, iterated 1, 3, 5, 7, 9, so on and so forth. And we'll use the exact values. And of course, that is a very long list, 500 values long. And so one of the things that I can do with outputs on Mathematica is I can have Mathematica execute an output, but not display the results in Mathematica when I execute it. So I'm going to now make this list. I'm going to assign it to a variable t1. I'll go ahead and make the list anyway, and then I'm going to suppress the output by putting a semicolon after the command. It will still execute this. It will still make this list t1, but it's not going to display it as an output for me, so I don't have this huge output in my Mathematica notebook. So let's go ahead and execute that. And now let's make sure that T1 actually has something in it. So again, my assumption based on how I have set up this list to be evaluated is that T1 should have 500 elements in it. And so let's look at the 17th element, and the way that I'm going to do that is I'm going to take that list, I'm going to put 2 square brackets, and then let's look at the 17th element of that, and then I'm going to close that with 2 square brackets, and that's a way I can look at a single element of a list. That's the syntax for looking at that, and that 17th element in the list is pi over 1089. So again, I can look at any particular element of that list that I want. Then finally, these lists can be used, for instance, in plots and other types of quantities in order to graph values that are in lists. So let's go ahead and do a log plot. Since it's a list of numerical values, I'm going to use a list plot, and I'm going to do it on a logarithmic scale. So this is list log plot, and we will just put in T1. That's the list that I'm going to look for the numbers in, and we'll go ahead and plot that. And you see that I obtain this plot of the numerical values that are in that list, each as a point. Now, if you're paying attention, what this plot shows on the x-axis is just the iterated value on the horizontal axis, because remember, there's 500 values in this list, and so the iterator goes from 1 to 500, even though the actual numerical value goes 1, 3, 5, 7, 9. And so there's actually another thing that I can do is I'm going to go back up to this table, and I'm going to now make a list of coordinate pairs. The coordinate pair is going to be n, and then just what the iterator is, and then the value, right? And so if you think about this, when n is equal to 1, it's going to put a 1 there, and then pi over 1 squared. Then when n goes to 3, it's going to put a 3 here, and pi over 9, and so on and so forth. And so I'm going to make this list of coordinate pairs. We'll go ahead and evaluate that. Now let's look. I've reassigned what T1 is, right? Because now I've executed this command again. I've got a new table T1. Let's look at the 17th element of that. And you see now it's the coordinate pair that is both n and the value. And now I can again list log plot that. And you see that now my x-axis is actually the value of n, not just the index in the list. And so I can make coordinate pairs like that in order to make a plot. Okay, lists are very powerful. Lots of good information in Mathematica help on lists. I've barely scratch the surface of lists. You can make lists of all kinds of different objects. They don't have to be numerical values. They can be graphical objects. They can be other types of things. Very, very powerful set of tools associated with how to work with lists in Mathematica.